Hello guys, welcome to all of you. In this question, here is a circuit, and in this circuit the current value I in this branch has been asked. So let us see how can we find out the value of current in this branch. So this is the circuit given, and let us assume this node is grounded. We apply nodal analysis to find out the voltage at this node, and 64 volt supply is connected between these two nodes. Since this one node is grounded, so total voltage will be appeared across this node. So at this node voltage will be 64 volt. Now here we can see that between two resistances these voltage is divided. So these two resistance will be in parallel and these two resistance will be in parallel. So let's solve this parallel resistances. Now we will get that 60 ohm and 40 ohm parallel resistance. After solving we will get this is 24 ohm, and this 40 ohm and 10 ohm resistances will be solved in parallel then this will be equal to 8 ohm. This 40 ohm and parallel 10 ohm resistance. Now this 64 volt is applied between these two nodes. This node is ground. This is the V1 voltage which we have assumed. Then now we can find out V1 voltage easily. Then V1 can be written as 8 upon the resistance between the resistance at which the V1 voltage is appeared. So this V1 voltage is appeared across the 8 ohm resistance. So V1 can be written as 8 upon 8 plus total resistance 24 into total voltage, that is a 64 volt. Then this value will be nearly 16 volt. As we have found out V1 is equal to 16 volt, then voltage across this resistance can be find out as it is 64 volt. So voltage across 24 ohm resistance will be 64 volt minus V1 volt. This will be equal to 64 volt minus V1 is 16 volt. This will be equal to 48 volt. So this voltage V24 volt and V1 volt is 16 volt. So as in this circuit we can see that the same voltage will be across 40 ohm and 10 ohm. So V1 voltage will be 16 volt and V24 ohm volt will be 48 volt. This is the 48 volt. Now we can find out current. So current in this branch will be voltage upon resistance, that will be approximately current. Let's assume this is I1 and the current in this branch will be I2. Then I1 current can be written as 48 volt whole upon 60 ohm, that will be equal to 0.4 ampere, and I2 can be written as 16 volt upon 40 ohm, that will be equal to this value will be 0.8 ampere, and this will be equal to 0.4 ampere. So I current can be written as by KCL at this node. Then I will be equal to I1 minus this current minus this current, I1 minus I2, that will be equal to 0.8 ampere minus 0.4 ampere. This will be equal to 0.4 ampere. So I will be equal to 0.4 ampere. This is our answer.